Hello, this is Math 111Z. We're starting 2.6 today, but before we start, we're going to do homework 2.5 part 2, number 16. So the example that I have is f of x equals 5x to the 10th plus 4x to the 6th plus 2x squared. And it wants to know if it is even, odd, or neither. To test that, we're going to put in f of negative x. So any place that I see an x, I'm going to replace it with a negative x. So this would be 5 negative x raised to the 10th plus 4 negative x raised to the 6th plus 2 negative x squared. And if you take a negative 1 and raise it to the 10th power, it's just positive 1. So for this one, the negative 1 goes away. Likewise, if you take a negative 1, raise it to the 6th power, it just is a positive 1, so that becomes this. And if you take a negative 1 and square it, you get a positive 1. So 2 times positive 1 is just 2, and then you get this. And you'll notice that this matches this. So when I put in opposites, I get the same answers out. That makes this even. Now, if you're struggling with this and you really can't see this whole x thing, I would recommend that you just use a number. So this also works if I just use a number and put in a number and evaluate the number. Let's variable because this seems like a little confusing to you. You could, for example, I took, again, this function f of x was 5x to the 10th plus 4x to the 6th plus 2x squared. Imagine if I just put a 2 in for x. So I'm going to grab my calculator quick. And I'm just going to type in the following things. 5 times 2 to the 10th plus 4 times 2 to the 6th plus 2 times 2 squared. So I'm just putting this right into my calculator.
And not close the door.
All right, so if I do that, I got 5 times 2 to the 10th plus 4 times 2 to the 6th plus 2 times 2 squared. And I get 5,384. Now I do the exact same thing, but I put in a negative 2 this time. So I got 5 times negative 2 raised to the 10th plus 4 times negative 2 raised to the 6th plus 2 times negative 2 squared. I do that on my calculator. 5 times parentheses negative 2, close parentheses raised to the 10th, plus 4 times parentheses negative 2, parentheses raised to the 6th, plus 2 times parentheses negative 2. Make sure you use these parentheses around your negative 2s or you're going to get an incorrect answer, squared. Hit enter, and I get 5,384. I get the same thing when I put different things in as when opposites in, same things out. That tells me that is even. So if you don't like testing, always just test with a whole number. And then if you get the same things in, you know it's even. If you get the same number out, but it's different by a sign, like one is positive and one is negative, then you know it's odd. And if you get 2 completely different numbers, then you know it's neither. All right, now we're going to do the 16 from part 2, which we'll take a quick look at. 16 from part 2 says, let f of x equal 1 over 4x plus 10. And we want to find the difference quotient, which is this.
Yeah, this is the one that's...
All right, so let's do it step by step. First, I put in an f of x plus h. So this is 1 over 4x plus 4h plus 10. That's what happens when I put x plus h in for x here. Distribute the 4, I end up with that. Minus f of x, which is just the same. This whole thing all over h. In order for me to simplify this, I need to find a common denominator. And you can't just like add a 4h to the top and bottom. These are sums and quantities. You have to treat them like they're their own factor. So I'm going to multiply this part by 4x plus 10 over 4x plus 10. And I multiply this part by 4x plus 4h plus 10 over 4x plus 4h plus 10. So on the top, coming from here, I have 4x plus 10. Then, coming from here, this part, not with the h, I have minus 4x plus 4h plus 10. All over 4x plus 10, 4x plus 4h plus 10, that whole thing all over h. Now let's simplify. So all I did was find a common denominator. Okay. So if I simplify 4x minus 4x, that goes to 0. 10 minus a 10, that goes to 0. And on the very top, I'm just left with negative 4h. Over this thing, don't bother factoring this out or foiling this out. You don't need to. That whole thing all over h. Right. Now, this is the same as over h over 1, so I can flip that up and invert and multiply. Again, here's my denominator. Just let it hang out there. Don't get too wrapped up about it. It's all good. Times 1 over h. These h's cancel. And I'm left with negative 4 on top. And on the bottom, 4x plus 10 times 4x plus 4h plus 10. And that's it.
So, question.
Yes.
The correct answer is a positive 4.
No, it's not.
Because that's what,
No,
negative
it's
over
not.
here. Okay.
Yep. That is not, yeah, there's a negative there. Okay? And, but yeah, this is the correct answer. And move on to 2.6. We finally get to the algebra of functions, which is delightful and fun, and you guys are going to love.
Are you being sarcastic?
No, not at all. All right. Tell me what are the operations. What are operations? Good. PEMDAS are operations. You have parentheses, exponents, multiply, what? Divide, add, and subtract. Turns out you can do all of those different operations with functions. So let's take the easy one, adding. You can take f of x plus g of x. Notationally, we might call this a f plus g of x, right? We might write it like that. Some books, just to make sure that they're clear, might write it so the f and the g are in parentheses as well. This is just kind of a new function name that tells us that we're just adding the functions together. So let's suppose that f of x is 2 over x minus 4, and g of x is 3x minus 1. Then if we add those together, it's just going to be 3x minus 1 plus 2 over x minus 4. You just add the pieces together. Adding functions is exactly what you would like it to be. Subtracting functions.
I don't want to even know.
exactly what you would think would be too. Yeah. So if I took f of x minus g of x, all I would do is take the f of x and I would subtract out the g of x. I can distribute that negative sign if I want. But that's it. Just subtract it. What?
Is that your answer?
Yeah. I could, if I wanted to, find a common denominator, but I don't need to.
Whoa. What? This is like a whole new world. Oh, that, if you just add.
Oh no. Okay, good.
Yep.
I was good for a second.
All right.
So you just factor the negative in, essentially?
Yeah, you just distribute the negative in.
What'd you do with the x?
Minus 4 on the bottom, nothing. It's just,
Oh.
I got a sloppy writing. Let me fix that for you.
Okay.
Yeah.
I thought you were doing something.
Nope, I wasn't trying to do anything. I was just being sloppy. Multiplying and dividing act exactly how you want them to act as well. So if I wanted to multiply f times g of x, you just multiply the two functions together.
Oh, that's for multiplying. Did you?
So this would just be 2x minus 4 times 3x minus 1. If I simplify that, that's 6x minus 2 on top and x minus 4 on the bottom. That's it. I'm done.
Oh, shoot. So what if you have f plus g times x?
F plus g of x. It's not timesing x.
Right.
This
Well,
is-
no, there's a parentheses around the f and g too.
Yeah, that's fine. This is just like saying, this is just its name. Its name happens to tell you that this is f of x plus g of x.
That's what I thought.
All right? You're not timesing anything. This is f plus g of x, which means you're adding those two functions together.
Okay.
All right? So those are the adding. And multiplying, and then dividing is exactly how you would want it. If you have f of g of x, that's just taking f of x, dividing it by g of x, as long as g of x is not equal to 0. If g of x is equal to 0, then the whole thing blows up, obviously. So in our case, f of x was 2 over x minus 4, divided by 3x minus 1. Okay, so if I want to simplify this, remember that we're just dividing fractions, which is the same as invert and multiplying. So I'm going to have a 2 on the top, and on the bottom I'm going to have x minus 4 times 3x minus 1. Now some questions might ask you to FOIL this out, but you really don't need to. Like there's no rule that says it has to be FOILed out. This would be an adequate answer in my book. So, all right, let's talk about domains. Obviously, this domain, for example, is not going to work when x is 4, and it's not going to work when x is 1/3, because those are the two numbers that make this bottom part 0. So if I wanted to write this in interval notation, I would say, okay, I'm great from negative infinity up to 1/3. Then I'm not so good. So I skip 1/3 and I go up to 4. Then I'm not so good. And then I skip and go up from 4 to infinity. Now in my open math, you probably need a union symbol here. In set theory, you typically wouldn't write the union symbol, but there you go. And that's what it would look like in interval notation. Okay?
Okay.
So let's,
So why do we need to put the 1/3 and the 4 in the middle?
so this, see how I don't have brackets here? No brackets means that number's not included. So that's basically saying go all the way up to 1/3, skip 1/3, go up to 4, skip 4, go to infinity. The only places that this function has a problem is at 1/3 and 4. And essentially, what's going on here, what this graph looks like, so if you look at the graph here, you'll notice I have an asymptote. What's going on here is right here at 1/3. We have an asymptote. So here are my two functions. Again, these are composite functions. So if I go from here, f of g of x, that is saying f of g of x. G of x goes inside. So that is f of negative 2x minus 4. That means wherever I see an x in f of x, I'm going to put minus 2x or minus 2x minus 4 there. So this is going to equal minus 2x minus 4 squared plus 1, which I can simplify to, foiling that out, 4x squared minus plus 16x plus 16 plus 1, which is simplified to 4x squared plus 16x plus 17. So that was f of g of x. Now, one thing that's really important to note is that while if you take f times g of x, you could switch it just like all multiplication and take g times f of x and they'd be the same. That does not work with composition. Composition is not a function that commutes. You can't switch it and have it not matter. So let's look at g of f of x. G of f of x. I switch the order. Do I get the same thing? So this would be g of f of x. That means g of x squared plus 1. This says wherever I see an x in g, I put, oops, that's not what I wanted. I wanted this. I put x squared plus 1. So this is equal to negative 2, oops, I see an x, so I put x squared plus 1 minus 4, which simplifies to negative 2x squared minus 2 minus 4, which is negative 2x squared minus 6. These are definitely not the same answers. So composite functions are not commutes. Let's do a handful more of examples. Let's say f of x equals x squared plus x. G of x equals the square root of x, and h of x equals negative 3x. What if they want me to find h of g of x, which is the same as h of g of x? Right? Actually, they want me to find h of g of 0. So this would say, put 0 into g. This is the same as h of the square root of 0, which is 0. And then put 0 into h, which is 0. So it's just 0. Let's try h of g of 1. This would say h of g of 1. What's g of 1? G of 1 is 1, so this is h of 1. H of 1 is negative 3. Let's try g of h of 1. That is g of h of 1. H of 1, I put 1 up here. That's negative 3. All right. G of negative 3 is the square root of negative 3. That's undefined or imaginary. So it's not a real number. It's the square root of 3i. Imaginary number. Imaginary. Not real.
So, what if it's f of 2 in brackets?
F of 2. F of 2.
Well, actually.
That works. We can do that. Let's do that one. We can do that. Let's do that one first, and then we'll take it from there.
Well, it's not that though.
Well, we'll just take it from here. We'll do this example, and then we'll go on to what the other one you want. So remember that f of x is equal to x squared plus x. So this is f of 2. So f of 2 is 2 squared plus 2, which is 6. So this would be f of 6. F of 6 is 6 squared plus 6, which is 42. So f of 2 is equal to 42. Right? All right, did you have one that you wanted to?
Is that the same thing? Because it says it has f, open bracket, f of 2, close bracket.
Yeah, same exact thing.
It's the same thing?
Yep.
Oh,
You put the f of 2 into, you put the 2 into f, get an answer, put that answer back into f.
gotcha.
All right?
That's what I thought, but they put the brackets there.
All right, I let you guys go ahead and take a whack at your problems, and then we will answer questions as you go.